everyone, welcome back. So in this video, we'll be going over an introduction to imaginary numbers, and we'll be doing that through the POV of a game that's described on the screen right now. So let's go ahead and take a look. So a math class played a game called Solve It, You're Out. At the start of each round, students choose a card from a deck marked with integers from -5 to 5. When an equation is shown, any student whose card states the solution to the equation is eliminated. 5 students remain. So let's take a look at part A. So the next equation that was presented is x squared equals 9. And the question is which students were eliminated, and we have to explain. So if we look at x squared equals 9, well, one of those solutions would be 3. So one student to be eliminated would be Fatima. And we can say that because if we put 3 in for x into the equation described above, well, 3 squared equals 9, so that's a solution. And there's actually someone else who can be eliminated, and that other student is going to be Mercedes. Now, the reason is because when I substitute -3 in for x into the equation above, we get -3 squared equals 9. Following order of operations, that would mean we want to take care of our exponents first. So we really have -3 times -3, which equals 9. That is a true statement. So in reality, both of these students are getting eliminated from the game. Another way that we can think about this is if we take a look at the graph. So x squared is a parabola. It's actually the parent function. So here's our parent function, x squared. And the question that's being asked is, where does the equation equal 9? Or where does the graph cross this value of 9 on the graph? And so there's actually two places, because we can see that the parabola crosses that linear line twice. It crosses it here. So that would actually be Fatima's solution of 3. So it crosses it there at 3, and then over here at -3. Okay, let's take a look at part B. So in the next round, the equation presented was x equals -4. Elijah thought he'd be eliminated, but this was not the case. And so now we have to explain why that's incorrect. Well, if we take a look, Elijah's number is -2. So let's substitute -2 into the equation. So we have -2 squared, and we're trying to see, does that equal 4? Well, -2 squared is basically taking -2 times -2. And -2 times -2 is +4. And +4 does not, so I'm going to put a slash to that equal sign, does not equal -4. So Elijah would not be eliminated. Elijah's going to stay into the game. If we want to visualize this on a graph again, we've got that same parent function of x squared. So we've got our red parabola. This time, -4, that y value is going to be underneath the parabola. So this is the equation y equals -4. Okay, so we can see that the parabola does not cross that blue line at all. Okay, so now in part C that they want us to summarize. So what is true about solutions x squared equals a when a is a positive number? Well, C is basically asking us to summarize our findings in part A. So we can see that if the y value is positive, or anything, another way to say that would be anything over 0, there will always be two solutions. Okay, so for example, if we draw this graph again and we've got our parabola here, when in part A they were asking us which students would be eliminated if x squared equals 9, well, if I drew in a value here at 9, we can see that the graph crosses twice. If I drew in another line over here, like let's say at 64, we can see that the parabola still crosses that blue line twice. Okay, and if we were trying to find the solutions to x squared equals 64, well, I know that if I put 8 in for x, that's going to give me one of my solutions. So one of my solutions would be 8, and the other solution would be -8. So x would equal positive or negative 8. Okay, then in part D, what's true about solutions to x squared equals a when a is a negative number? Well, that's a lot like part B, where we had questions like x squared equals negative 4. Another example of that would be x squared equals negative 36. So for here, if the y value is negative, and I'm just going to put a minus sign and circle it, or anything less than 0, there will be no solutions. Okay, and we can visualize this on a graph again. Okay, so there's our parabola of x squared, and if I draw in the line y equals negative 4, we can see the parabola doesn't cross. And if I draw in something like negative 9, we can see that the parabola does not cross. Well, today's lesson is going to be about imaginary numbers, so we're going to modify our answer here, and we're going to say that there will be no real solutions. And we'll discuss a little bit more about what that means in the next video. But let's go ahead and take a look at part E. So how about when a equals 0? Well, if we take a look at the equation, x squared, and we're trying to see when a equals 0, we're going to put a 0 in for here. We can ask ourselves what number times itself will give us 0, and the only answer there is 0. And once again, let's visualize this on our graph. So we've got x squared. So here's our parabola, x squared. Okay. And 0 would mean that our horizontal line is going to be right here on the x-axis. So that's going to be y equals 0. And we can see that the graph crosses it once right here at the vertex. So when a equals 0 for x squared, there will be one solution. Okay, because there's only one number where when you square it, it's going to give you 0, and that number is 0. All right, thanks for watching. Let's head on over to the second video where we're going to define imaginary and complex numbers.